Oh hey there, this is section 2.4, multiplication with negatives. Your essential question for the day is, how do negatives change the way I multiply? This is another review section, so a lot of the things I'm going to say should make a lot of sense to you, like you've heard them before. Here are some rules. If you have a positive times a positive, hopefully you remember that that equals a positive. And our verbal example, because if we think about the English language, these rules make a lot of sense. So the verbal example is, if I say I am going to party, isn't that all positives in that statement? I am going to party. And doesn't that mean that I am, yes, in fact, going to party? Definitely. But let's say I have a negative times a positive. In other words, there's one negative there and one positive. That's going to equal a negative. And think about what it means in the human language or the English language. It means if I were saying I am not going to party, doesn't that mean the negative? Like maybe somebody else is going to party, but you're sure not. Here's the negative. That not, since there's exactly one of them, means you're not going to party. So that's what it is in math too. If you have one negative, yeah, that negative's going to win. But let's say you have a double negative. In English, a double negative means a positive. And that's what it means in math too. If you have a negative times a negative, it is a positive. The verbal example, I am not going to party. See how there's a double negative there? If you are not going to party, doesn't that mean you're actually going to party? Doesn't that mean you're going to be doing something like this? I think it does. So a double negative means that, in fact, you have a positive. There are some other rules that we can use. So before the problems, let's just talk about a couple more properties. First of all, we have the commutative property. The commutative property says, hey, 2 times 3 is 6, but also 3 times 2 is 6. Looks like I can do multiplication in any order I want. The associative property says that I can group my multiplication differently. So let's say I have 1 times 2 and then times 3. Let's see, 1 times 2 is 2 and then 2 times 3 is 6. Isn't that the same as if I put the parentheses around the 2 and the 3? 2 times 3 is 6 and then 1 times 6 is still 6. So if you didn't catch what I did there, I moved the parentheses to do a different part of the multiplication first, but I ended up with the same answer. And these two properties together basically let me move my multiplication problems around however I want. Really useful. The identity property, if I multiply any number times 1, doesn't it just equal itself? So that's the identity property. That'll help us a lot. The inverse property. The inverse of, for example, 8 is its reciprocal. And by reciprocal, I mean flip the fraction. So the reciprocal of 8 over 1 is 1 over 8. And when I multiply those things, they cancel to 1. So the inverse property can help us cancel some things and not have to worry about the fraction multiplication. Finally, property of 0. If you multiply anything by 0, what's the answer? It's always 0. No matter what you multiply times 0, the answer is always 0. And did I say last? I was wrong. We also have the property of -1. If I multiply, say, 8 times -1, sort of like the identity property, I'm going to end up with 8, but isn't it going to be -8? So multiplying by 1 keeps it the same, but since that 1 is negative, I know that a positive times a negative is going to be a negative. Let's say I had a -8 times a -1. Negative times negative is positive. So basically multiplying by -1 flips the sign. Let's use these properties in some super awesome fun math problems. There are just 4 examples today and they'll go really quick, but I want to see if we can make use of some of the properties we just talked about. First of all, in example number 1, I have 2 terms being multiplied together. Remember how there's multiplication in here? Since I have 2 negatives, those are going to cancel. Remember, I'm not going to party. That means I actually am going to party. So my final answer is going to be positive. I don't even need to write that. Also, do you see how I have a 6 here and an over 6 here, a 6 in the denominator? Remember the inverse property from the last slide, this one? If I have a number on top of a fraction, so 6 over 1, and a number on the bottom of the next fraction, those are going to cancel because of the inverse property. So the only thing I'm left with is 5x, so that's my final answer, positive 5x. And I made use of a couple properties to get there. For number 2, I have negative 3 times negative 4 times negative 5. So let's think about what happens with the signs first. I know that the first two negatives are going to cancel out to a positive. But then I have this extra negative hanging around, and I know from the English language if I have just one negative, that means yes, my answer is going to be negative. I am not going to party. There's just one negative left since the first two canceled, so my final answer will be negative. At this point, don't forget that I can do the multiplication in any order I want. In this case, it'd probably be easiest just to work from left to right, but because of the commutative property, I could also work from right to left. Doesn't matter. Anyway, let's work from left to right. 3 times 4 is 12. And 12 times 5, well, 12 times negative 5 is negative 60. Don't forget about this little x hanging out at the end. He doesn't really have anything to multiply with because there are no other x's. So negative 60x is my final answer. 2 more problems and then we're done. How exciting is that? First of all, let's take a look at the signs in number 3. Since I have just 2 negatives, it's the not partying situation, so that means my final answer will be positive, which remember means I don't have to write anything. Let's do any order that I want. So let's take care of the numbers first. I'm doing 7 times 1 over 21. Don't forget that it's a fraction multiplication problem. I'll do it over to the side here. For fraction multiplication, I'm going to do 7 over 1 times 1 over 21. And don't forget that with fraction multiplication, if I see something on the top and the bottom that can reduce, I can do that reduction before I multiply. So in this case, I know that 7 over 21 reduces to 1 over 3. And now my multiplication's easy. Top times top, I have 1 on the top. Top times bottom, I have 3 on the bottom. Nice. So 1/3 will be the coefficient or the number in front of the variable in this problem. I still need to take care of this x and this x, and hopefully you know this, x times x gives me x squared. So here is my final answer. Notice how by doing things out of order, I could organize the numbers with each other and the variables with each other. Let's finish with number 4. I have another fraction multiplication problem, but before I do that, let's take care of the signs first. I have just one negative, and remember, when there's just one, that means that, yes, I'm actually not going to party, so I will have a negative in my final answer. Let's take care of the fractions first. Remember that when I see something on the top and the bottom that will cancel, I can do that before multiplying the fractions. So I'm going to reduce this 9 over 3 to 3 over 1. Now top times top gives me 3, bottom times bottom gives me 10, and I've taken care of the numbers. As with the last problem at the end, I have x times x, which remember is x squared. Final answer. Hey, those weren't too bad, right? Just remember about canceling within the fractions. Remember that x times x gives me x squared. Remember that you can do the multiplication in any order you want because of the commutative property. And don't forget that 2 negatives make a positive, and you'll be good to go. So your summary for today is negative times negative equals positive. And don't forget to study your properties because they will help you to multiply more intelligently. And will I test you on the properties by themselves? Yes, I will. Hey guys, thanks for watching. See you in class tomorrow.